Yeah, hello everyone. My name is Mr. Lang and I teach computer science at Gull Lake High School in Richland, Michigan. With the help of Kyle Bennett, one of my amazing students, we've been working on designing and creating a self-watering system. And I think today we're going to test it out and see how it works. But before we do, let me go ahead and run over some components that we have to make this a reality. First of all, behind this monitor here, you're going to see a couple solar panels. We have a smaller white one and then a nice big larger one. We know the larger one will sustain our battery power with the solar light, but we're going to test out this smaller one and see if that will help maintain it. Behind the scenes here, we do have a 12-volt battery. And that is running our system and again being charged by the solar panel. Now here in the front, first and foremost, we have a regulator. We want to only provide 12 volts to our Arduino microprocessor, and so coming in we have 12.6 volts, and then going out right now we have only 12 volts to keep that regulated. All right, and then that brings us down to our Arduino board. We're using an Arduino Uno, and then we also have a shield on here to keep track of our data. We'll be able to track the different sensors, which we'll talk about here in a little bit's data, put it into our laptops and pull up an Excel spreadsheet and track the data. We're going to be making some cool charts and see the different, the health of the project as well. So up above here we do have an LCD screen. That LCD screen will provide our user data for us to see from our light detection. This will determine the lumens in the room. So light. Right here, we don't have it here yet, but that will house our temperature sensor. It's on our breadboard right now, right about there. If you can see that small temperature sensor right there, very hard to see. Sorry about that, but eventually that will be relocated up to there. We're just testing it out, and it seems to be working pretty good right now, which leads us to our breadboard. And as you can see, this is where everything is getting connected, from our valves to our sensors to our LED lights to all sorts of stuff. All right, and then over here we have our water bottle with water in it right now, and it's not leaking, which is a good thing. And we have our valve. This is a basic 12-volt valve that will open and close when needed, and you'll see how that will work here very shortly. And then down below here we have our soil, and eventually we are planning to put some seeds in it and hopefully grow some beautiful flowers inside of our computer science room. You can see a couple wires going into it. One wire is going into a sensor that will determine temperature of our soil. Another sensor, let's bury that again, another sensor will determine the moisture of our soil. So you'll see how those work here in just a little bit. Let's go ahead and push that back down. Let's put some soil around that. All right. And I think, well, I should say also, everything you see in green, we 3D printed. And we 3D printed quite a bit of things through our engineering part of our computer science class. You can see we broke a few things. We had to re-engineer things and everything. But you know what? That was pretty fun. I enjoyed watching Kyle really go back and design and redesign and get the actual style and these clips, if you will, kept breaking, so making sure that we had the right density and everything. We weren't using too much filament. We weren't using too little as well. So very cool. Everything that is in green, we 3D printed. Even our bottle to half-inch PVC pipe is in green. And so everything is holding up pretty good. Nothing's leaking, which is a cool thing. We do have a couple valves here. And the reason we have a couple valves is, first of all, this one's on right now, letting water flow through it. And this one's off. If we ever need to transport our project, we can then go ahead, and if we still have water in the bottle, we can open this valve up, put a nice jug or something underneath here, and then get the water out of there for transport without turning it upside down, because we actually feed the water in up here. But eventually, when this is outside and we have a big old system, we'll have a nice catch basin to catch our water from Mother Nature and everything. But I think that's about it. Are we ready to plug it in and see if it works? Let's test it out. So here we go. All right. things are coming on. Our LCD board is coming on. We have our LED lights that wrap around it. Right now, the LED lights are green, which is a good thing, meaning that the soil is very happy. There's not too much moisture in it. There's not too little in it. It's set pretty good. And so a little bit about our LED lights, we set it to where if the soil is really dry, those LED lights will be red. If the soil has way too much water in it, those will be blue. So that way we know that, hey, it's getting overwatered, and we know what could happen to plants if they're overwatered. So again, kind of a visual cue for us. Some pretty cool LED lights that we have running there. I love LED lights. So let's see. Let's pull that sensor out because this is brand new soil. So that is some good, nice, moist soil right out of the bag. And so let's pull this this moisture sensor out and see what happens and if it comes on. And here we are, red, and our valve opened. Oh, our valve opened. I should have left that sensor out a little bit. It's red, and the valve only opened for 1 second. All right, and it's still red. The soil, let's just pretend the soil is still thirsty. And we didn't want that to continuously be on until the sensor really sensed that the soil is moist, because when water goes into the soil, it takes a little bit to disperse throughout the soil. So we have it come on for 1 second. And then we have it set up in our code to wait 20 minutes, take another reading. If the soil is still thirsty, needs water, if it's still dry, the valve will come on for another 1 second, and then wait again for another 20 minutes and test the soil and see where the data is and if it needs more water or not. Again, if it was blue, there'd be way too much water. And so this is the point where Kyle, my programmer, we're really going to look at some of the data and determine, do we need to tweak any of the numbers? This is our first time running this. Is the soil not wet enough? Maybe we got to go back into our program itself and tweak a few things, but that's the fun part of it. We really enjoy doing those types of things and tweaking it and going back to the iterative process and doing it over and checking things out again and pulling the SD card out, checking our data and doing it over and over again. We're going to also, once we get that tweaked, our plans are, so stay tuned for part 2 of our video, we want to put a wind detection sensor up on top of there. Now, I know we're inside and we're not going to have wind in here, but we are planning on putting like a computer fan or just a basic fan up there to hopefully blow the wind sensor a little bit, just to kind of pretend that we're outside. And then obviously when we do take this outside, we will get real-time data from Mother Nature, but we're going to put a sensor up there. So stay tuned for that. But hey, there's our project. I'm going to leave the moisture sensor out of there just to test, to make sure in 20 minutes from now that is going to come on for another second, and just test it out for a little bit and see how things go. So I hope you guys like our project. Again, Kyle's been working very hard on this, so thanks, Kyle, and big and better things are coming, so stay tuned.